We are in the condition we are in the state of ignorance we are in the state of war, in the state of economic depression, in the state of depletion of the resources of our planet because of the greed of psychopaths who thought they could create their own reality. Well, look at the reality they created.
You're listening to Sott Talk Radio, the world for people who think.
Hello and welcome to Sott Talk Radio. I'm your host, Neil Bradley, and with me in the studio this week is Jason, Juliana, and Scott. So the title for this week's show is Physician Heal Thyself, Disease and Modern Diet. Pretty weighty topic, but we'll try and make some light of it too. We're going to be discussing with our very special guest, Dr. Dwight Lundell. Dr. Lundell is the former Chief of Staff and Chief of Surgery at Banner Heart Hospital in Mesa, Arizona, where he also had his own private practice. After spending 25 years performing over 5,000 heart surgeries, Dr. Lundell left surgery about a decade ago to focus on the nutritional treatment of heart disease. He is the founder of Healthy Humans Foundation, whose vision is to, quote, help the human race free itself from chronic diseases caused by improper nutrition and misleading consumer information. Dr. Lundell has published 2 books, The Cure for Heart Disease and The Great Cholesterol Lie. Welcome, Dr. Dwight Lundell.
Well, thank you very much.
Thanks for agreeing to be on our show. Thanks for being here.
Hello.
Hello. I think your name will be familiar to a lot of our readers because, and our listeners today, because your article, Heart Surgeon Speaks Out on What Really Causes Heart Disease, I think it was one of the most popular we ever had.
I think we get a huge number.
Yeah, it was.
People really liked that article.
I think we picked it up, and then someone else picked it up, and next thing you know, it literally viral.
Yeah.
It went around.
Wasn't somebody saying that Rush Limbaugh was talking about it?
I think so. Yeah, he referenced Sott and this article, and he was talking about it. And I don't know what the chain of events was, but it was heard far and wide, which is cool.
It's kind of like, Satan talking about,
That's not cool. Yeah, well,
like,
not so sure.
It's like if you're the Pope and Satan's talking about you, then you done right. You done right to everything,
Well, it was interesting. My son called me and said, you're going to be on Rush Limbaugh in a few minutes, and he spent a half hour and went over into the next segment and read the entire piece, and apparently he loves Sott.net.
Oh, I see. Did Rush Limbaugh then get you on his show?
No, he did not get me on the show, but Fox News had me on 3 times to comment on heart disease.
I see.
What did Limbaugh say about it? I'm curious because when I was growing up as a teenager, I used to watch Limbaugh all the time because I just thought it was hilarious. But I mean, what was his spiel? Do you know, Dr. Lundell?
Yes, I do. I listened to the show, and I think what appealed to him was that we were going against the government's current dietary recommendations. But he read the whole article and on his show.
Wow. Awesome. Well, you began it with a confession in which you admitted that you had been wrong about the cause of heart disease. Now, considering this is, I don't think I'm wrong in saying this is an epidemic. But what is it? 80 million people have some degree of heart disease or other. What's wrong? Where do we begin this? What is it that officially has been so wrong?
I had one of my very smartest professors in medical school told me when I was a young student, the worst thing that can happen to a patient is a diagnosis. Well, that puzzled me greatly because I thought we were here to make a diagnosis. And his response was that when we make a diagnosis, then everyone stops thinking about what's wrong.
I see. So the diagnosis.
Think about, that's profound. Right. I mean, we put a name on a disease, and we think that means we understand it completely. And he used a little example of certain diseases, if we don't know the cause, we call them idiopathic. And his response to that was the doctor is an idiot and the patient is pathetic. So his advice was that we should always keep our minds open and look, and if we don't really honestly know the fundamental biology of a disease, then we really don't understand it, even if we have some treatment that's moderately effective for it.
What can I ask you, it seems when I encounter doctors, now I'm kind of ignorant about this because I'm not really a scientific person or scientific minded or anything like that, but I have a lot of experience with doctors as a patient.
Oh,
and it's my understanding. Yeah, it's unfortunate. I've spent quite a lot of time in hospitals and spent time in a hyperbaric chamber as well, healing after surgery. So I've met specialists of all kinds, and the one thing that I've really noticed about them is they never seem to know what's wrong. And so I really want to know, how much does medical science really know about disease to begin with? I mean, they all say so that they're so sure, but I mean, what does medical science know about heart disease? Like, really know, like a fact about it, You see what I'm saying?
Well, we know a lot more. We know a lot more than we did, for example. When I first started in school, we really had basically no effective treatment for heart disease, and there was a lot of excitement about heart disease because about 90% of the young soldiers killed in the Korean War had some form of heart disease, some of them relatively severe, and so there was a lot of excitement about it, and we really had no treatment for it until the coronary bypass came along. So to me, we could take someone who was near death and do this little coronary bypass, a little rearrangement of the plumbing, and give them back their life, give them back to their families, give them back to their wife. And so even though I didn't understand the disease, I had a solution for it, at least a temporary solution that really worked 99% of the time. Mm-hmm. So I think that's what happens a lot of times in medicine. If we discover somehow that there's a treatment that's effective, then we'll use it even if we don't understand the fundamental biology of what's going on behind the scene.
Yeah, that's something very interesting that you said in your book, actually, which we're highly recommending to all our listeners because it's really, really well explained. And you make a comment at one point. You say, I had become a mechanic, and it's great to have mechanics, but why is there a need for mechanics when we can prevent hearts from breaking in the first place? And, maybe you can expand a little bit more on that in terms of how medicine is nowadays.
Sure. I mean, cancer, for example, we don't know what causes cancer. We have lots of treatments for it. Mm-hmm. We can cut it out. We can burn it with radiation, or we can try to poison it and everything else with chemotherapy. And indeed, for some cancers, we really have a very effective treatment. We understand some of the biology of cancer cells, but we don't really understand what triggers it in the beginning. And so our ability to prevent cancer in a wide array of things, because we don't understand what causes it, we can't prevent it. Now, some of the nutritional strategies involved in treating heart disease are also important in cancer, but nevertheless, we don't fundamentally have an understanding why suddenly cells would begin to divide abnormally and turn into a cancer.
Mm-hmm.
Yeah, when it comes to heart disease, on the one hand, we've got the mechanics working the best they can with what they know, but it's been underpinned for decades, in fact, nigh on a century, by what has turned out to be an assumption about cholesterol and its dangers. Can you expand on that a bit? I mean, cholesterol, I did some research before the show, and I would trying to get information on this, and sort of a timeline of cholesterol and how it became a fundamental basis for treating heart disease and other illnesses. And I realized that I was searching in cholesterol theory, and what the results I was getting was that they were criticisms of this idea that cholesterol. What that told me right away was that it was maybe it once was considered a theory, but it had very much become fact. So I think this is going to be key to understanding how it all went wrong here. What was it about cholesterol that made it the number one target for treating people with heart disease?
Well, you've read the history recently, and correct me if I'm wrong, but old pathologists going all the way back to Virchow took a look at the plaque that was in the artery, and indeed there was cholesterol in the plaque. And so I think that's what started him and other people thinking about cholesterol, was that here was something abnormal inside the artery, and it contained cholesterol, so there must be a connection of some kind.
Right.
Is that how you read the history?
Yeah, exactly. That they were seeing that there was a buildup. Well, as I understood, it was a buildup of cholesterol that encases itself around a person's arteries, and that this was the problem. And step by step, that leads to the recommendation that people lower the amount of dietary cholesterol they're taking, and that's how we came to get the dietary recommendation that people eat a low-fat diet. And what's clear to me from what you've been saying, and others too, is that we seem to have gone in completely the wrong direction based on this assumption that the problem was cholesterol to begin with. Does that sound about right?
That is right, and I cover some of the history of it in the book, about who some of the major players were and how it developed. But yeah, it started because we looked under the microscope, even crude microscopes, 150 years ago, and saw cholesterol, and then we started experimenting, and we fed large amounts of cholesterol to a rabbit who's fundamentally a vegetarian biologically, and saw that lesions developed in the arteries, and so then the famous Framingham study was started in Massachusetts to observe people over long periods of time, and they made a correlation between cholesterol levels and the incidence of heart disease. And it just began to build momentum from there, without anybody ever asking why in the world would a normal substance that we produce in our liver and that every cell in our body need, why would it collect in the wall of the blood vessel?
Absolutely. Well, maybe for those listeners who are not familiar with this topic, could you pretty much summarize a little bit what you say in your book? You start by saying, that half of the patients that you saw with heart problems had normal cholesterol levels. So that could be a cause. And many of the studies prove that it's not the cause of heart problems. It's just maybe a consequence of the inflammation that starts way before. When you talk about us being time bombs, So could you explain, just in simple terms, the principle behind inflammation and why cholesterol ends up there, and what type of cholesterol, this bad cholesterol that everybody talks about, why is it there, and is it really bad?
Whoa, you gave me a big topic to make very simple there, but
no problem.
I'll try, because it's very important. We can make observational studies, we can do epidemiological studies, and we can do correlations and whatnot, but that never tells us the fundamental biology, and that's where we have to go to understand all of the diseases that afflict us. So once again, we made a diagnosis about heart disease was elevated cholesterol, and all we had to do was either bypass the lesion or or treat it with a cholesterol medication, or along in the mid to late 80s, along came angioplasty, a less invasive way of treating it, by sticking a little balloon in the artery and blowing it up, and then that was followed by putting a little piece of metal in there called a stent. Well, when the stents began to fail and reclose very quickly, that made us wonder about our diagnosis. So once again, we'd all stopped thinking about what was wrong until we had a treatment that wasn't working. And so that's when people began to take another look back at the fundamental biology of what goes on in this blood vessel. And that's when we went back actually and looked at Virchow's work from 1880 or whatever, and saw that he saw indeed, not only did he see cholesterol in the wall of the blood vessel, but he saw white blood cells. And white blood cells, as you know, are inflammatory defenses. They defend us against the bacteria and viruses and everything else that comes along. So not only was there cholesterol, but there was active white blood cells and a bunch of dead white blood cells and a bunch of decayed cholesterol in the wall of the artery. And so as people began to look at angioplasty and why they failed, we began to see that it really was fundamentally inflammation was the only reason that cholesterol would ever collect in the wall of our blood vessel. Now, let me back up a little bit and say that inflammation always follows injury. I mean, if we're never injured, then we never have inflammation, and injury can either be viral or bacterial or chemical, but there has to be a little injury for these. And once there's an injury, then a cascade of events happens that's called inflammation. And if we didn't have acute inflammation, we would die from every infection or injury or virus that came along. So we need it. It's fundamental to us.
It's a kind of warning system.
It's like a protection system, you know.
Absolutely. It's our defense. And what happens is the white blood cell is triggered by this cascade of chemicals and signals, and it becomes very aggressive. And if it sees anything that's abnormal, anything that's antigenic or that it recognizes abnormal, then its job is to gobble it up and eat it. That's what's called a phagocyte.
Right.
And so its job is to eat a bacteria or a virus or debris or foreign particles of any kind. So that's fundamentally the job of the white cell to defend us, is to go out there and kill the enemy by actually eating it.
Yeah. Phago meaning eat.
Okay.
And so what happens then is if we do something that injures the wall of our blood vessel, or if we injure us somewhere else and we have all these inflammatory signals going on, then the lining of our blood vessel, which is called the endothelium, which is really the key cells that control our blood flow and whether our blood clots, and if you stop and think about it, everything that we take in, the air and the water and everything else, has got to go through that endothelium to get to our cells. So it's a key critical layer, not only in controlling our blood flow, but in controlling what goes in and what goes out. So if this gets injured, or if there's an activation of inflammatory cytokines, then the white cells go into the wall of the blood vessel, and they're looking for the bad guys to kill. And if a bad guy comes along that's an LDL that's normal, there's no antibody on a normal LDL. It goes right past. They ignore it. But if it sees an LDL that has been oxidized, that LDL is now abnormal. Or if it sees an LDL that's glycated, that is, it has a sugar molecule attached to it, it deems that one as abnormal. And it gobbles them up because it thinks it's an enemy. And that's fundamentally how cholesterol gets into the wall of our blood vessel, by being gobbled up by an inflammatory cell.
So basically, what you're kind of saying is the crud that's inside the artery is basically white cell excrement from it gobbling up abnormal-looking cells. Just to see if I follow, because I'm not a science person, so I don't know.
Yes. It basically is for some reason, these cells can't completely dissolve and destroy the cholesterol that they take in.
Right.
Fundamentally because it's abnormal. And so if you look at this white cell under the microscope in the wall of a blood vessel, it looks like it's got little bubbles of fat in it, and it's got its name called the foam cell. And this is the very, very beginning of heart disease. So you're correct. It's basically excremental white cells, if you will.
Okay. No, I'm just because my mind is like so simple. I can't really follow the scientific stuff. So I mean, I'm just because like you're dancing around the issue, but you're basically saying, I guess what it is that there's these abnormal reactions going on, and the white cell, the inflammation starts. The white cell goes in there because it's like inflamed area, need to take charge, must eat, brains kind of zombie cell thing. Goes in there, sees all this stuff that's now weirdified, consumes it, pushes it out the back end, and that's what's left in there, which is really weird, to be honest. The human body is a strange thing.
Yeah.
Well, what's really interesting here... Sorry, go ahead.
No, go ahead.
Well, I was just going to tell you that what's interesting is that you say, the cholesterol was there for a purpose. It has protective functions. It wants to be recycled in the body. It's essential for the living organism. But when the sugar comes in, that's when the real problem starts. Hence, sugar is the culprit, not cholesterol, right?
That is correct. And the way sugar is a problem is because it causes inflammation in these endothelial cells. And there's a reason for that, but we'll back up and just say that when these endothelial cells are injured by high sugars, then the white cells and the cholesterol, for that matter, come there to fight the enemy and to repair the damage. And once again, the only LDL, so-called bad cholesterol, which is really false because it's a low-density lipoprotein, it's a big particle with cholesterol in it. But when that particle gets oxidized or glycated, that's when we have trouble.
So, yeah, but one thing is, like, I was always very confused because people were, like, saying sugar was bad for you, and I was surprised to find out that when it comes right down to it, sugar doesn't necessarily mean that white stuff that you put in your coffee. Doesn't sugar mean other things? It's like the foods that you eat get converted into sugar inside your stomach. So if you're eating like a piece of bread or you're eating some sort of high processed food, even though it might say on the back there's X number of sugar, when it goes into your stomach, it gets broken down, your body is actually getting a whole bunch of different types of sugars and breaking them down, right?
It takes a whole lot of different kinds of sugars and breaks them down fundamentally into glucose, and you'll remember the chemical formula for that, right?
No idea.
C6H12O6.
Yeah, okay.
At any rate, yes, we only absorb glucose and fructose, and maybe a few other little simple molecules, once again, that are broken down into the 6 carbon elements. So if it's a potato, if it's a piece of bread, if it's some delicious pasta from south of you there in Italy, it's broken down into glucose and into our bloodstream.
So it doesn't really matter if it's bio or not bio, it's still going to end up being sugar in your body, right?
Correct.
So there's sugars and then there's like fats. There's like stuff like that. So there's only those 2 types of things. When you eat food, they're going to get broken down into like amino acids and things like this, right? Can you explain that process? Because I'm curious.
Yeah, there are 3 macronutrients, actually. You mentioned 2. Carbohydrates is one, fats is another, and proteins are another. And so those are the 3 macronutrients that we need to survive. And as you pointed out, we need certain things are called essential because the body can't produce them. And we have 21 or so essential amino acids, and we have a few essential fatty acids that we can't make that we have to consume. Interestingly enough, there's not an essential carbohydrate.
Yeah, because your body even apparently it makes them out of protein, what it gets from protein and glycolysis or something like this. I can't remember. I read some Wikipedia page about this.
Yes, we can. Fundamentally, if you go without fat, you'll die. If you go without protein, you'll die. If you go without carbohydrates, you make enough. You can produce enough carbohydrates in the liver from protein and a little bit from fat, and to provide the glucose that you need for those cells that only can use glucose. But lots of cells are very happy, and in fact, much happier burning fat than they are carbohydrates. Although carbohydrates are, as you've read, supposedly the easiest source. Just because it's easy doesn't always mean it's the best source.
Right.
Absolutely, yeah. Well, some of us, we have a discussion forum where we talk about all these subjects, and Laura, who unfortunately is not here, she actually had a very interesting experience way back in, I think it was 2006. It's too bad she's not here because she tells stories better than I do. But anyway,
go on.
She had a herniated cervical disc, and they gave her a ton of steroids, an anti-inflammatory drug. And for the first time in her life, she had lived with chronic disease problems since she was 9. She had arthritis at the age of 9.
She was in pain,
constant
her
pain.
whole life.
And then from one day to the other, when she got that massive dose of steroids, she was pain-free. And she was like, well, wait a minute. This is, an anti-inflammatory drug. I must have inflammation. She didn't know what living pain-free was. So we started researching all that. And then, first of all, we started, we found the research on gluten, casein, grains in general. And several of us decided to give it a try and eliminated those from the diet. And it made a huge difference because, you already remove a bunch of toxic carbohydrates from just eliminating gluten. And then we found the paleo diet, or, some people found the Atkins diet, but mainly we moved into the paleolithic diet, and it made a huge difference for a lot of our group members who said, I'm pain-free, I don't have any, people even curing diabetes, and things really, really, it made a drastic change. And now we're, since, 2011, we started trying the ketogenic diet. Have you heard about it?
Oh, yes. How's it
and
working?
What's your take on it? Well, for most of the people whom we heard of, it's really, really working great.
I could tell a little bit of a story about that on the whole diet thing. So, I started getting really fat, actually, probably when I was about 9 or 10. I started to get pudgy. People started making fun of me for being fat. And as I got older into the teenage years, I was when I was 14, I think I was 240 pounds or something like that, I remember. And finally, when I got to I was about 25, 26, I weighed over 340 pounds, about. Yeah. I was very, despite being very fat, I'm also naturally athletic, which everyone knows, I do all kinds of crazy stuff. And even though I have a lot of girth, I've also got a lot of muscle mass. I can, lift a lot of weight. But I also had this thick layer of fat over my body. And I went to this doctor because I have a genetic disorder called Verneuil, which is hidradenitis suppurativa. And I went to this doctor because I had one of these things, and he said to me, "You're morbidly obese. You need to come under the knife. We're going to tie your stomach off with this." They install this ripcord into your stomach, and it's got a hole outside your belly, and you're supposed to tighten it or something. It was totally insane. So I felt really, really bad about this, and and then I got sick, with some what did he call it? Sigmoiditis. It was just sort of random inflammation of the colon. And I had this repeatedly, over the years. My colon would become very, very painful. I would have, blood in my stool and all this different stuff. And I went to a doctor, and the doctor said, "Okay, we have to give you a colonoscopy." And I said, "Okay." He said, "For the next 2 days, you need to be on a non-residue diet." And I said, "Well, what's a non-residue diet?" And he's like, "Well, basically, we need to clean out your colon and stop the irritation so that I can go in there with the camera.
Stop the inflammation."
Yeah. And in order to do that, you have to clean it out a bit, so you can't eat any vegetables. You can't eat any fibers. You can only eat some meat, and maybe like a little bit of mashed potatoes or rice, basically. And so, like, when, my mom was there, and actually Juliana was there at the time, and it was just sort of like this light bulb came on, because here's this doctor, he's about to, stick a camera into my colon, look at it, and he's saying the thing that's going to calm it down so that he can inspect it and clean it out is for me not to eat fiber and to only eat kind of like meat and just sort of non-residue food. And so then I said, well, why don't I just eat that all the time? Why don't I just stop eating those grains and stuff? So that's what I did. And I lost 64 kilos, which is what? It's almost 100
some pounds. Yeah.
Yeah, it's about 130 pounds. I lost 130 pounds. I mean, I'm not completely, hyper skinny and stuff. So I went on that. Basically, I stopped eating rice, which was like my staple food. I stopped eating any of that. I just sort of ate, kind of like meat and fatty stuff, and every once in a while mashed potato or something like that, something that would be really easy on my colon. Totally cleared up the problem. I stopped having the swollen colon. Like every, 3 to 6 months, I would have like these horrible cramps and blood in my stool. That stopped. I had, what did they call it? Irritable bowel syndrome. I had really bad irritable bowel syndrome, and that just completely disappeared, and so, I mean, that's kind of like my story with my experience of one of my hospital experiences where. Yeah,
so like Jason, then we have several stories like that of people who stopped eating what's recommended in the nutritional pyramid, basically, and they cured all kinds of problems. Now, we're into this, researching still this ketogenic diet, but I don't know. I'd like to hear what you think about it. Do you think it's something you would recommend?
Well, the answer is yes. I just, before this conversation, I said that's carbohydrates are the one macronutrient that we can actually live without, because we have the capacity to produce the small amounts, maybe 200 to 200 grams that we need, we can actually manufacture. And lots of cells prefer fatty acids and ketones over glucose and function better on those things. But over and above that, the idea that some things are inflaming our intestine, and that's a big bunch of inflammation, because the surface area of our intestinal tract, if you laid out all of it flat, completely flat, it'd be about the size of a football field.
Yeah, it's a lot in one person.
So, in you, when that's inflamed, that's why you were so sick. Now, it wasn't all inflamed, but lots of it was, and lots of it apparently was inflamed from the gluten and other elements that are in grains. And although the people with true gluten sensitivity, in a medical diagnosis are not rare, but they're not that many. The people with minor reactions to it who don't get overly symptomatic, now maybe they're just as gluten sensitive as anybody else, but they don't have quite the dramatic response. So lots of athletes, professional triathletes that we know of who had huge amount of GI troubles during events, so we're able to calm those all down and compete with by eliminating grains from their diet. And Bill Davis wrote the book Wheat Belly.
Mm-hmm. Yeah.
I don't know if you've seen that one, but he's a friend of mine, and we've corresponded actually for quite a few years now about this and that and the other. And while the gluten, I think he's right on, and he reports every day about reader after reader with stories similar to yours who were suddenly much improved in terms of irritable bowel and all those kind of things by eliminating wheat from their diet. Now, he proposes that I'll back from that. Over and above that, over and above the toxicity from the gluten and the gliadins, the toxicity from the high amounts of carbohydrate we get from most foods made with wheat is just as important in inflaming our blood vessels as gluten and gliadin are in inflaming our bowel. And so when we eat wheat, we get a double whammy.
Yeah, we could even add a third branch to that, the psychological impacts. I mean, of course, if you're inflamed and or in pain, you're not going to be thinking straight. That's something that, for myself, I had no obvious physical symptoms, that were telling me something was wrong when I was eating a regular balanced diet, lots of carbs. But making a change and testing out, upping the fat intake and reducing the amount of vegetables and so on, it is an amazing effect on your concentration levels, on your ability to be productive, your energy levels.
Here's one thing that I've noticed that nobody really talks about or is told, and I don't know if it's consistent across everybody, but I do know that it's something that I have definitely noticed. When you cut out carbs, okay, you do see improvements. But then if you try to go back to the same level, I mean, if you go off processed foods and high carbo, high sugar, all this different stuff, you go off that, and then you think you can have a hamburger from McDonald's, or you think you can have some French fries or something like that, and you go and have it, it hits you like a ton of bricks. Okay? If I eat anything, I can detect if things have gluten in them. People will say, oh, it doesn't have gluten. I went over to somebody's house and they used something, they put a sauce on it. I said, is there any gluten in it? They said no. I ate it. I knew it had gluten. I know it because I have a very strong reaction to it.
That's your warning system. That's the inflammatory kicking in your favor.
Worse. It's gotten actually worse. My reaction to it has gotten stronger, more clear. So that if I have something like, high carbohydrate processed food, that hits me like a ton of bricks, and the next day I feel like total crap.
Is that something you can confirm, Dr. Lundell, from your patients or people who talk to you about, becoming more aware of the sensations they get?
Oh, absolutely, yes, and that's why I called wheat the double whammy. Not only do we have the reaction in the wall of the intestine that then triggers off all of those cascades of irritable bowel and allows lots of bad things to get in our blood that shouldn't get in there because the bowel wall is so inflamed and doesn't work properly. But over and above that is the high glycemic index of all of these products that are made out of flour. They can call them whole grain Cheerios, but that's a lie. I mean, you can go out in the field and get a handful of wheat in your hand and chew it up, and it turns into gum. That's gluten. It's glue, is where the word came from.
Yeah.
So if we don't take this wheat and grind it very finely and process the heck out of it, you really can't eat it. I mean, I don't think I could survive on real kernels of wheat because once again it turns into gum. But
one thing that's interesting. Go ahead.
Well, I was just going to say that. That's all right. The other thing that Dr. Davis says is that elements in wheat are addictive.
Yep.
And I don't know, I don't want to argue with him, but I don't know for sure if it's the glucose or the gliadin that's addictive, or both. I won't argue that, because we know that glucose is addicting and triggers the pleasure centers in the brain very much like other drugs of addiction, cocaine and morphine and heroin and all those kind of things. So the pleasure centers, the dopamine, all the rest are, if you do a PET scan, the same centers get activated. And as you look at people that overeat, just go to the buffet and watch. And it's compulsive behavior. And you look, I mean, you were a smart guy. You controlled many other things in your life, but you can control what you ate. And it's an addiction. It's not as quick. I mean, the results and the complications are not as quick as the addiction to drugs are, but they happen, and they're just as strong, in my opinion. And that's not to diminish the tragedies of drug addiction, but what's not tragic about diabetes and an amputation and dialysis and blindness?
Exactly.
They're just as an heart disease. They're just as tragic, and they come from this element in our diet called carbohydrates. I gave a talk a few weeks ago on the low-carb cruise, and I said the most toxic molecule in the human diet is glucose.
Mm-hmm.
And somebody tweeted that out, and it caused a bit of an uproar, saying that I didn't understand anything about physiology because glucose is necessary, and on and on and on. It's kind of funny.
Yeah, well, they would, being junkies. Well, I mean, I've noticed, because when people come to visit, they freak out when there's no bread on the table, and they ask things like, "Don't you have any bread?" And we say, "No, we don't eat bread." And they're like, "You don't eat bread?" And it's really kind of actually a bit funny too. It's sad, not really funny, but it is sort of like you see them freaking out that there's no bread. And it's like when it's not, when it's just there on the table and everybody eats it, nobody thinks about it. But when there's no bread on the table, people will actually they'll come to our house, visit, and then they'll go out to eat. Oh, no, no, you guys just eat by yourself, right? And they go out of their way to be really polite. No, it's okay. Yeah, no, you don't have to cook for us. No, we'll just go out and find something. And they're like going out to get their fix type of thing. It is kind of sad. And people feel sorry for you, like, oh my God, you're living such a restrictive life. How do you keep beating yourself up to stay on it?
Well, here's the thing.
The thing is, you don't crave it anymore.
Well, people like that, I do kind of want to, I'm not going to say anything like that. I mean, because being a person who was fat for most of my adult life, realizing at a certain point, because when you're in it and you're eating that stuff all the time, like he was saying before, you go to a buffet and you see these people going up, and a lot of people sort of laugh at it or think it's funny, they mock it, or they make a moral judgment about it. But having been somebody who was in that, who was one of those people at the buffet, you just are not in a place where you can see that there are so many wonderful things in life to do, which eating is such a small part of your life and should be such a small part of your life. And for people who are compulsive eaters, eating is, everything to them. It's something they do, something they look forward to. It's the only thing that assuages whatever it is. It fills the hole. It makes them feel better about themselves. And so you have these other people, you live such a restricted life. And I say, but I used to not be able to, go for a run or skateboard or do any of these other things because I was so fat. So you know what? I'm happy eating a restricted diet if it means I can do these 5, 10, 15 other things that fulfill me much more than food does. So, I mean, I have a strong reaction to people who say that.
So why aren't we told these things, Dr. Lundell? Why is it that the government keeps promoting grain so much and carbohydrates, and that almost every single doctor you go see tells you about the balanced diet nowadays? And why is it that it's kept so, separate from what should be?
Well, it's a combination of bad science and bad government.
Uh-huh.
And the bad science I talk about a little bit in the book, and it starts back with, feeding a vegetarian animal cholesterol and looking at heart disease, and it moves on to, I think one of the most important players is Ansel Keys, who wrote the 7 Nations Studies, wherein he correlated the consumption of saturated fat with heart disease. And so that became a key piece that everybody quotes to say that saturated fat raises cholesterol, cholesterol causes heart disease, therefore we should eat no saturated fat. Mm-hmm. And the sort of sad thing that nobody paid attention to at the time, well, some people did and raised objections, but it got overruled, and that is that he had data from 22 countries, and he cherry-picked the 7 that met his preconceived notion. And even over and above that, on page 256 of this 7-country study, he admits that there's a correlation between the consumption of carbohydrates and heart disease. But he covers it up by saying, well, when they ate more carbohydrates, they also ate more saturated fat. Therefore, it's the saturated fat and not the carbohydrates that's causing heart disease. So he had a fundamental bias, and he ignored the data and manipulated the data, and God rest his soul, he's dead now, but I think he bears responsibility for this epidemic of obesity and diabetes, in part.
I think that it's interesting that the power that scientists have today to cause damage in people's lives is really actually sometimes a bit scary and horrifying. That the casual self-interest of one man, or even maybe it was just a psychological kind of like, he just liked his carbohydrates and just couldn't admit it or whatever it was. But I mean, there's a lot of suffering in the world because of that.
Oh yes. And, George McGovern, the senator that chaired the Senate committee in the United States that issued the dietary guidelines, also recently passed away. But that committee was just as guilty of bias. They hired a vegetarian, a vegan, as a matter of fact, to write the report. They were completely biased. They ignored the protests of many scientists. That this wasn't the answer, that fat wasn't the problem, and that replacing saturated fat with vegetable oils wasn't the answer, and that replacing fat of any kind with carbohydrates wasn't the answer. But he's famously quoted as saying, "We don't have time for all the science to come in. We have to do something now."
Yeah, the science is settled. Let's just get on with it. And what they got on with was recommending a low-fat diet, the very thing, it would seem, that has been central to causing this explosion in heart disease, diabetes, and everything else. That's just insane.
Absolutely insane. And one more thought about the compulsion. Never, ever have I seen a compulsive eater going for the butter, or going for the cream, or going for the sauces. They're going for the carbs.
No. Yep.
Never once.
You hit your limit, you find satiation, and you leave it. You get on with other things. I was going to ask you, how, after reading your article, my first thought was, how did it all go wrong? We've touched on it here. I mean, the influence of one guy in particular, Ansel Keys. But I mean, from there was science being done in parallel that contradicted this idea. But still, even to this day, even when there is more information that directly contradicts, such as the information that you pulled together, it's still the dominant idea that you need a balanced diet, you need a low-fat diet. It just staggers belief that they can still be recommending this in the face of the evidence that it's so tragically wrong.
It's tragically wrong that we keep recommending it. And unfortunately, it involves, in this day and age, it involves money. And I think that in a couple of years that we will see PhD theses in business analyzing how the drug makers influenced regulation to such that everybody now needs a statin medication. It was absolutely brilliant. It wasn't out-and-out bribery. It was much more subtle than that. They would say, "Dr. Lundell, we recognize you as a great authority in heart disease, and would you please give a talk? And at a convention, and we'll pay your way and to a fancy place and put you up, and you can be the authority, and you educate your colleagues on the evils of cholesterol and the benefits of taking this medication." Well, that's irresistible to a lot of people. And if I'm a university researcher and my tenure and my salary depends on research grants, and I can go to a big drug company and say, "Look, I need $100 million to do XY study," and if they think I'm influential, then I get $100 million, and that gives me a huge amount of power. And then I get my buddies who agree with me, and together we sit on the National Cholesterol Education Panel, and we make all the recommendations.
Yeah, you cite my papers, I'll cite yours.
But that really makes me angry. The whole thing about statins, and I'm hoping you will say something more about this, because there's an amazing amount of people who take statins for life.
Dr. Lundell has written that a quarter of all Americans are taking statins.
And I mean, the list of side effects, when you can fix, you mentioned that one thing that statins will do is reduce inflammation, right? Maybe.
Maybe.
That's not even proven.
No.
That's not even
proven. No.
All their claims about reducing heart diseases, it's false, right?
Yes, absolutely false.
Absolutely. Okay, so they've been lying to the public, and we see people with Alzheimer's with like serious problems, memory loss, what else, diabetes, anything. How come that they keep lying to people, and that people are just, is it? It just makes me mad. Sorry, but
I think somebody did a little film recently. I don't remember the title, but at any rate, there's 30 billion reasons to recommend statins. Bernie Madoff, the famous fraudster in this country, is in jail for cheating people out of 30 billion over 30 years.
With his Ponzi scheme.
Which a Ponzi scheme? Well, we spend more than 30 billion in the United States, worldwide on statins, and we spend another 100 million on testing and doctor visits. And we recommend statins to healthy people. It's become in the United States a standard of care. And with the electronic medical record, if I'm a doctor and I don't recommend statins to someone who shows up on that record with a high cholesterol, then I've fallen below the standard of care and I'm guilty of malpractice. If that person should have a heart attack for some reason or another, then they would come after me for liability for that. So that's how deep and how dark this has become, in that I'm almost breaking the law if I don't prescribe it to you, whether I believe it or not.
Jesus Christ. Never mind that it's associated to 300 diseases.
Well, listen, there's some recent evidence that statins cause an increase in the rate of diabetes.
Yeah.
So if we have 25 million people in this country on statins, and 10% of them get new diabetes, that's 2.5 million cases of new diabetes. If there was something in our water that caused 10% of the people to get diabetes, we'd go to the ends of the earth to get rid of that compound, whatever it was. And yet, we punish our doctors if they don't prescribe this other poison. And my very first professor in heart surgery always called them liver poisons, statins, because that's exactly what they do. They prevent the liver from producing cholesterol by inhibiting an enzyme. So he called them liver poisons, and I always liked that.
And as far as I understand, they deplete your body of coenzyme Q10, right? CoQ10, which is
yes, they do.
The most beneficial thing for your heart health.
One of the most, yes.
Unbelievable.
Juliana, you were saying earlier today that someone has suggested we start pumping statins into the drinking water?
Yeah, there was a UK scientist, I don't know if you've heard about that, Dr. Lundell, that they were saying that statins should be put in the drinking water.
Yes, I've heard that, and there also was, it's been around, the idea had been around for a long time about a polypill, which would take an aspirin and a statin and a low-dose blood pressure medicine, that everyone should take it. Well, sort of the sad thing is that statistically, there's the nice-looking pharmaceutical rep, the young lady with more than ample bosoms, had come to my office to bring me articles about statins, and of course most of the doctors read the abstract, and who can even concentrate on the abstract with an attractive young lady there telling you about the benefits of this statin over that statin. But over and above the crass nature of humanity, but it's just that nobody reads the data, and we think it's authoritative because it came from a university, and little did we know that they really had to work hard to manipulate the statistics. I don't know if you've ever heard the term p-hacking.
No.
No.
Well, the p-value is a statistical term, meaning it's statistically significant. And so if you play around with the numbers long enough, you can get it to be statistically significant. And so that's what's called p-hacking. If you play with the numbers long enough, then you can get what's called statistically significant. Well, the sad thing is that that then is interpreted to be a significant difference. What to you and me a significant difference is black versus white or sick versus healthy. But to a statistician, a significant difference means that it's more likely than random chance to be correlated.
Okay.
That's all statistically significant means. More
So
likely
this
than
means 51%
not.
as opposed to 50, and a coin flip.
Yes, basically, or, you know, more likely than not to be, 51% likely to be not a random circumstance.
Wow.
Right.
So when you see, and then they also invented this term called relative risk, which which changes it. If I drive with the windscreen of my car, how do you like that? For throwing in a British term instead of windshield. Anyway, if I drive with a dirty windshield, and my chance of a wreck are, if I drive with a clean one, it's 1 in 100. If I go a year, then I have 1 wreck. If I have a dirty windshield, I have 2 wrecks. So you would say I doubled the risk of a wreck by having a dirty windshield. The relative risk is doubled. The actual risk is that I'm only have 1% more chance. But by calling it relatively risk, it suddenly becomes 50%. And this is the way it is with statins. You know, you see the Lipitor ad, 39% less chance of a heart attack. Well, that's relative risk. It means that that's just what it means. If you take 1,000 patients and put them on statins, 1 will have a heart attack. If you take 1,000 patients and put them on no statins, then 2 will have a heart attack. The difference is explained by lots of other factors besides statins. And yet we say, look, you've lowered your risk by 50%. Who wouldn't want to take this?
But you haven't really, because...
Yeah.
No, you haven't.
Yeah.
You've changed it from 1% to 2%. And the likelihood of that is only 2%.
But let me ask you, this might be a stupid question, but, you know, there's a lot of people who have supposedly, they're told that they have to take statins for life. Now, is it possible that somebody who gets informed and stops or reduces their carbohydrate intake and everything might be able to get off these drugs without any problems? Because that's an argument that I come across very often. You know, well, I can't stop them now because I got a stent and I can't stop the medication. Or the doctor told me that it was better to reduce it by half but keep taking it. Is that true, or is it still part of the whole propaganda for statins?
I'd call it a manufacturer's dream if I can make a product that you need to take the rest of your life.
Exactly, that's what I'm thinking.
I've suddenly got an annuity that I don't have to renew. I have an annuity forever. Once again, the only evidence that statins help anybody is in a very limited population. And I have some questions about whether that data is valid. But an honest physician or scientist will tell you that middle-aged males with previous heart attacks have some benefit from statins. You can't deny that it has never, ever been proved in any other population to be of any benefit.
Except in people who have had a heart attack, middle-aged men, right? That's what you're
Correct.
saying.
That's the only population where there is a statistically significant difference in the outcome. And the outcome means heart attack or death from heart disease.
But at what cost? And have these people who make part of this conclusion have been off carbs? I mean, is it really scientifically proven? Has it been compared to a low-carb diet? And is it safe to let go of them if you're willing to?
Oh, of course it's safe. I mean, unless you're in that population of a middle-aged male, and I don't think you'll ever get there.
No, not Juliana.
You don't need a statin.
But the question being is, if you're a middle-aged male, okay, giving you this, you're a middle-aged male, or a later middle-aged male, maybe even, and you've had 1 or 2 heart attacks, you had a stent put in, and you've been prescribed statins for life. There you are, popping your pills every day, bopping along. suddenly you get this idea in your head, you know what, I don't want to take them anymore. I'm going to try this other thing where I will stop. I'll manage my diet, manage my stress and everything like that. Cut out the processed foods, cut out the carbohydrates, cut out the gluten, cut all these other things. Can you actually stop taking statins at that point? Like if you've committed to doing something else and you've started to see some health benefits from cutting out gluten and cutting out carbs, and then can you stop taking the statins, or will you drop that immediately?
Okay, let me ask you a question then to answer your question. If cholesterol is not the cause of heart disease, how stupid is it to take a medication to lower your cholesterol and subject yourself to all the side effects from that medicine?
Well, exactly. That's what I'm saying. I mean, even the argument that middle-aged men with a history of a heart attack would need this medication sounds crazy to me, because there is a much more natural solution. Okay, it's proven to have some effects, but did it have effects on people who were already making changes in their diet? Or are we talking about the guy who had a heart attack and still keeps eating at McDonald's?
Well, I'll go back to my statement. If cholesterol is not the cause of heart disease, then lowering cholesterol is completely idiotic.
Mm-hmm.
Completely idiotic. And so before we leave, I want to come back. We talked about some fundamental biology of how the cholesterol got in the wall of the blood vessel, and we talked about carbohydrates. But sometime in this conversation, I want to get down to the biology of the endothelial cell and see if we can figure out whether sugar hurts it or not, and how it does, how it might.
All right, well, let's go there. Let's dive in.
Okay, well, there's a, I'll mispronounce the French, I'm sure, but there's a term called milieu intérieur.
Perfect.
Yeah.
Did I do okay?
Yeah,
and
perfect.
it means internal environment.
Yeah. Mm-hmm.
And the other word we use for that is homeostasis. That means that our body likes things to be stable. We control our temperature, for example, in a very narrow range. And we work very hard to make that temperature in a very narrow range. If you don't believe that we have a strong desire to keep our carbon dioxide and oxygen in a very narrow range in our blood, just hold your breath for a few minutes.
Yeah.
See how strong the body's desire is to keep those levels normal. Mm-hmm. If our sodium, for example, gets too low, we die. If it gets too high, we get really sick. And the range is relatively narrow. Same for potassium. Same for lots of things. So the body likes to control all these things in a very narrow range. Glucose is one of these things that it likes to control in a very narrow range. So we'll go to the basics of blood sugar control. And that is, when we consume carbohydrates, our pancreas senses an elevated blood sugar and produces a hormone called insulin. Insulin then triggers a glucose transporter to transport the glucose inside of the cells. The primary purpose being to control the level of sugar in the blood, glucose. We'll use the term interchangeably. It might not be 100% accurate, but we'll use it interchangeably. And so when the glucose comes back within the normal range, the pancreas stops making insulin. If the blood sugar goes a little too low, the pancreas senses that as well and makes a hormone called glucagon. Glucagon tells the liver, take some of this glucose that you stored and converted into glycogen, convert it back to glucose and let it go into the bloodstream, so we keep the blood glucose in a relatively narrow range. So those two hormones fundamentally control the level of sugar in our blood, even though we eat carbohydrates intermittently.
Mm-hmm.
Now, there are insulin-sensitive glucose transporters. It's called a GLUT4. And it's most predominant in the liver and the muscle and in the fat. And these are the big reservoirs. If you go out and have yesterday was National Donut Day in the United States. So if you go out and have 2 or 3 donuts,
oh, God.
Was it really?
Yes, it was.
Yeah. Oh dear.
And if you go out and have 2 or 3 donuts, that glucose is going to go into your liver until it's full, and then the liver is going to make fat out of it, and then it's going to go into your muscle until they're full, and they're going to say no more, and then all the rest has got to go to the fat cells to be stored in relatively long-term storage. And those cells have a GLUT4, which is very sensitive to insulin. Now, many other cells are not. They have glucose transporters that are not insulin sensitive. And critically, one of these cells happens to be the endothelial cell, which lines our blood vessels, all 60,000 miles of them. This endothelial cell, the glucose inside is the same as the glucose in the bloodstream because it can't say no. So what happens when we get too much glucose inside the cell? We get what's called, well, let's back up and say that we turn, life really is, if you want to make it back to simple chemistry, plants take sunshine and carbon dioxide and water and make energy. And we take, and the energy is glucose, because that's what plants make in in simple molecules, all the way to fiber and all the way to seashells, for example, or carbohydrate. But at any rate, then humans take, and animals, we take that glucose that the plant has produced, and we extract some energy, and we produce carbon dioxide and water. That's, that's fundamentals of life for that simple chemical equation. But when we take glucose and produce energy out of it, we move electrons from one molecule to another. It's called oxidative phosphorylation. And in that process, we always end up with molecules with an extra electron. That molecule is called a free radical. And those free radicals, if they're not neutralized pretty quickly by removing that electron or adding another so as a total pair, actually that's what happens is we add another to pair it up, that molecule becomes toxic and damages cells. And this mitochondrion, they produce these free radicals all the time, and at a certain nice homeostatic level, everything is controlled. The free radicals are neutralized. Think of it as a furnace in your house at the winter. Your house is nice and toasty. There's a nice little controlled fire down there. Someone comes along and dumps a bunch of gasoline on that fire. It becomes an out-of-control fire, and it's a mess. Well, that's what happens when we dump all the glucose into the endothelial cells. We have a mess. And
an internal fire, inflammation.
And an internal fire, inflammation, absolutely very good. Now, think about diabetes, which is characterized by high blood sugars, and the unique set of complications that go along with diabetes. And they are blindness, kidney failure, limb amputations, and premature death from heart disease. So diabetes is sort of the extreme example of what happens to everybody when they have high blood sugars from our high carbohydrate diet. And it all goes back to two things. One is the oxidative stress that occurs. And we just overload our little energy factory. And as a function of overloading it ends up with bad byproducts. And those bad byproducts are free radicals. And those, the experiment's been done. We take endothelial cells in a chamber and expose them to high glucose, and you see them curl up, and you see them change shape. They no longer make the same chemicals they did. That's called endothelial dysfunction. So they don't work anymore. And so fundamentally, we watch the telly in the United States at least, and there's 15 ads for ED. That would be erectile dysfunction. But really, it's endothelial dysfunction that's causing the erectile dysfunction. And so my talk, I gave a couple of talks recently. ED, no, not that ED. At any rate, so when you think about the fact that the endothelium controls our blood flow, whether it clots or not, what goes through it, what it passes back into the blood, when we have endothelial dysfunction, we have lots of other dysfunctions. And it can be subtle, and it can take a long time to happen. Now, in the article, I talked about a sunburn or a wound where you did a wire brush. Well, I'll use a sunburn example. You can go out and get a sunburn once, and next day, day and a half later, it's healed. But if you get that sunburn 6 times a day for 30 years, your skin will be a mess. So my statement is that we're sunburning, we're injuring the lining of our blood vessels every time we have an overdose of carbohydrates. And over time, this causes those blood vessels to have inflammation, to scar up, and this is why the blood vessels in the eye go closed and I go blind. This is why the blood vessel in the kidney closes and I can't make urine anymore, and it's why the little tiny vessels in my toes plug up and I get a foot ulcer and then I get an amputation, and it's why plaque builds up in the coronary arteries. It's
is this also related to problems with blood circulation?
Yes, when the endothelium doesn't work, then the blood vessels can't dilate or contract, so that gives us hypertension.
Yeah.
Now there are other things. Let's be honest. There are other things besides sugar that can injure the endothelium. Cigarette smoking, for example. We know that. Other chemicals of one kind or another, and bacteria, and all sorts of things can do it. But the most common injury that we get, and some things we can control and some things we can't. The most common injury we get is hyperglycemia or high blood sugar.
Yeah.
So fundamentally, if you can control that one, then you can work on the rest.
I got a small question. So I'm a contrary person, to be quite honest. I mean, you know that. You've probably met people like me before. When somebody says everybody knows something, I'm the first person to say I don't. So,
okay.
Because I'm just that way. It's part of my personality. So when you say that everyone knows that smoking damages such and such, and my first response is, well, I don't know it. So maybe you could tell me a little bit about that.
Oh, okay. And actually, thank you for calling me on that, because that's not something a scientist ought to say. Is everybody knows.
Yeah. Okay.
So thank you for insisting on that. Let's keep this down to science and fundamental biology. Actually, those experiments have been done. We measure endothelial function by what's called flow-mediated dilatation, or we put a cuff on the arm and blow it up and stop the circulation for a little while, and we open it up and we see how much bigger the blood vessel got and how much more flow occurs. So if you do the test and have a certain amount of flow, and then you smoke a cigarette, and you will have less flow.
I see. What kind of cigarette did you smoke?
A Gaulois, whatever the
a Gaulois.
Gaulois.
Oh
yeah.
dear.
Oh God.
Oh, that's a bad
It doesn't make much. At any rate, we also look under the microscope and expose the cells to those things, or we take an animal and we smoke, and we then look microscopically at the blood vessels. And so when I say everybody knows, that's incorrect. The data is in demonstrating that the chemicals in cigarette smoke damages endothelial cells.
Okay, so we agree that it's the chemicals. It's not. It hasn't been proven that it's tobacco per se, right?
No, it's and I don't know if we've isolated exactly which one. I don't think it's the nicotine, for example. It's the other things that come from burning.
Well, here's the thing that makes me very sensitive about that. There's a thing called the Truth Campaign. I don't know if it's still going on. Do you remember that? It was years ago in the U.S. When I was growing up, there was something called the Truth Campaign. And they basically got like poppy-looking kids from Abercrombie and Fitch, and they would like run around and do these things telling people about how cigarettes are going to kill them. And one of the things they did is they created this big billboard, and they put a list of all the chemicals that are inside of a cigarette. And there was a lot of things like formaldehyde, arsenic, and a couple of other number of chemicals that actually are kind of like everyone knows are listed as being like toxic chemicals. And I was like, well, did they grow in the plant? No. And so they had this big list of all these chemicals. And then a few years back, there was this brand of tobacco that came out called American Spirit. And their big thing was that it was all natural tobacco grown by Indians on the reservation or whatever it is, right? And that was their whole thing. But the Surgeon General made them put a little disclaimer on them that says that just because it's natural tobacco does not constitute a safer cigarette. And I said, no, hold on a second. If I have a choice between 2 glasses of water, one of those glasses has 1 drop of arsenic and the other one has half full of arsenic, one of those glasses is safer for me to drink just by virtue of there being less of a poison in it, right? I mean, it's just pure logic. You know, if I had to drink one of those, I would pick the one with 1 drop of arsenic as opposed to half full of it, right? I mean, because I have the ability to think. So that immediately kind of like alerted my contrary, wait a minute, hold on a second, that's not right, that's not logical. And so that makes me very sensitive about it because, you know, people will say, well, we did this study with cigarettes. And I said, yeah, but there's like 80 brands of cigarettes. Which one did you use?
Yes.
And then they'll say, I'll say it's important, you know. What was in the cigarette? Was it just pure nicotine? Did you inject the nicotine in and see what happened? You know, so, yeah, I get really sensitive about that.
Oh, well, I think you're absolutely correct there. And once again, it's sort of big brother, big government preaching at us. All the data on secondhand smoke, I think, is pretty dubious. Although there might be something to it, but
can I say
and
one
you're
thing
correct
about that?
Go ahead.
About the whole secondhand, this whole thing that secondhand smoke is worse than the first, right? That was this mantra that they had for years, and it's so idiotic because if I'm in a room and I'm smoking a cigarette with somebody who's not smoking a cigarette, I'm getting the first hand and the second hand. So secondhand smoke cannot be worse than the first because I'm getting both. And the other person's only getting the second hand. So that it's illogical. It's just the product of a puerile, ignorant mind.
Well, doctor, we have to confess, we're 4 people sitting here at the studio, and the 4 of us are smoking. But we promise we're smoking 100% natural tobacco. So it's kind of a sensitive topic, and we do deal with it, and we have done some research about it, and it's really amazing how, you know, the whole propaganda about smoking started, and there's doctors even like you know, who said I've opened thousands of lungs, and we have one here. Neil was reading it earlier, and she says, you know, it's not possible in any way to distinguish between the lung of a smoker and a non-smoker, you know, and it's true, you know, it's part of this, in my opinion, it's part of this government campaign, and if they care so much about our health and they're, you know, bombarding us with things about smoking, why don't they talk about carbs?
Yeah.
Well, not too long ago we couldn't talk about smoking.
Mm-hmm.
Because tobacco was so influential with their lobby, and
until Hitler came along.
So big tobacco controlled the conversation until the data on cancer and whatnot became
until carbs and drugs became more important.
So big sugar and big soda are now the big tobacco. And in fact, Gary Taubes and another woman have just, in Mother Jones, recently did an article on expose on the data that big sugar had hidden about how they tried to influence regulation. And they were part of this process. Ansel Keys got big grants from the Sugar Association to do studies. And so once again, the same thing that went on with a big pharma in promoting statins, big sugar has done for years. And the nice thing is there's beginning to be some sensitivity because Coca-Cola has got all these ads now about happiness in children and sharing and trying to say that their product is not as happy and good and all those kind of things.
This is the same product they clean Chevy engines with?
There is a lot of research out there that frankly counters the assumption people have when it comes to tobacco smoking. One thing is very interesting that it ties into our discussion today is that smoking tobacco is anti-inflammatory.
Pure tobacco.
Oh, I haven't seen that one, but that's interesting. Not all smokers die prematurely. Only about 20% do. I think I mentioned that in the book. I've never been a smoker except as a teenager, but
I wonder
if we make an informed choice, knowing a risk, then we ought to be free to make that choice.
Exactly.
But what's happened with sugar is that we didn't get a chance to make an informed choice. We still don't have an informed choice. If you choose to be obese and hyperglycemic, as long as you know that you're going to be sick and unhealthy and die prematurely, I don't care how much you eat or how much all the rest, as long as you assume the risk. And unfortunately, I have to pay for that risk because I'm part of the insurance pool that pays for your illnesses. And so in a real way, I'm subsidizing your bad choices. Now, I'll admit that you don't have the information to know that it's a bad choice.
And this, I'm thinking, is what is motivating you today to tell people, to educate people about this issue. You realize that people are not informed because they don't have choices before them, and this is what motivates you to get them thinking about what's really going on here, namely that their diet is the key to understanding what is wrong with them. And not just you, of course, you've come from the background of being a heart specialist, but I think it's clear from our conversation today that you've realized that all these things are connected. I mean, just about every ailment can be tracked back to the same fundamental underlying problems. I think it's great that you're doing this, and I really just wish more people would. I'm sure there must be others who have been there, done that, who do have access to the real science, so to speak. I just wish more people would speak out like you have.
And not get as much attack as you have too, right?
Right. There's a British doctor named John Yudkin who wrote a book called Pure, White, and Deadly. And Ansel Keys and all his supporters destroyed him, his reputation, because he dared say it was carbohydrates and not fat that was causing these illnesses. And his book, Pure, White, and Deadly, it's not as fun as reading a novel, but it's good and contains the information that he knew, and he presented this, and he and a bunch of other people tried to bring this out when we were making the dietary guidelines, but they once again got overwhelmed by Keys and his allies and big government.
Well, I'm a big fan of juxtaposition. Just to understand something. I mean, back in the days of the Enlightenment, when science was still called like natural philosophy, one of the big problems that everybody had was that they were making observations in the real world, things were happening, and the church wasn't really able to explain them. And when people tried to explain them, they did things like put them on trial for heresy and punish them in various different ways, and that kind of led to a revolution against the church. And you see today that you have almost the exact same problem, but in reverse. You have people who are making observations about reality, about the world, about the health of people, and you've got scientists who are, half of them burying their head in the sand, and the other half of them are in this Eichmann-esque kind of position where they're just sort of signing the papers that are sending people off to the health concentration camps in a certain sense. I mean, just basically sending people to their deaths, and we all say, oh, it's understandable because they want money. Well, no, it's not understandable. I mean, if you sign a piece of paper and a lot of people die, you killed them. It doesn't matter if you did it with a pen or if you did it with a knife or you did whatever, you're responsible. When you tell lies to get money that lead to people's deaths, then you've done something fundamentally evil. And so that's kind of the way I see this whole situation, and I wanted to get your opinion on that. That the kind of the situation that we find ourselves in is that science has become a very religious organization with a kind of a priesthood that then puts people on trial. Sometimes actually quite real. People do get put on trial when they dissent and speak out and say, "Hey, the observations are wrong." No, the Earth doesn't travel around the sun in a certain sense, and then they're put on trial for various different things, and they're slandered and driven sometimes even to their deaths or to suicide or other types of things. So, what do you think about that?
I think that's brilliant. Actually, I had the privilege of having dinner with Dr. Robert Atkins' widow a few weeks ago. Mm-hmm. And there was testimony in Congress that he was killing people, and he endured withering attacks from his colleagues in medicine in general for trying to repopularize reduced carbohydrates and saying that the fat wasn't damaging. Now, the other amusing thing to illustrate your point is that I watched a video of a big conference on insulin levels, and there's a whole lot of diseases associated with high insulin levels. So these researchers are going on and on and on about insulin levels and this disease and insulin levels and that disease, and I'm screaming at the screen and say, "Yo, what is it that causes high insulin levels?"
Seriously.
Nobody would dare say the G word, glucose. Nobody would dare say it, and so this illustrates your point of the priesthood of science. And if you dare say that the globe is not warming, you're a denier. And if you say fat's not harmful, like I do, then I'm a fat denier, and I'm discredited, I'm reviled, and all the rest. But there's a nice quotation that says, "In a time of universal deceit, speaking the truth is a revolutionary act."
Yeah. George Orwell.
Yeah.
George Orwell.
It's dangerous to be right in matters where the established authorities are wrong.
Yeah.
Yep.
It still applies today. I mean, they'll hit you in different ways, of course.
Right.
But it's the same as ever.
Yeah, I mean, I think that the problem is that we've always tried to solve the solution by turning over authority to different sets of people. First we turned it over to the authority of kings, and then they kind of screwed us over, and so then we said, oh, well, now we need to turn the authority over to this, over to religion, turn the authority over to science, and each time we just keep turning the authority and the responsibility for making informed decisions and getting ourselves informed over to other people. We want a scientist to tell us, or a doctor to tell us, what's true or what's false. And I think that the lesson that people should take away from it, I mean, it'll probably take us another 10,000 years before we actually figure this one out, but if we survive that long. But basically that you have to make your own choices pretty much, and that if you keep turning over things to a select group of people, of an authority, you're just going to get led down the primrose path into pain and suffering. And, how many people a day die from heart attacks or heart disease or something like that? What was it, 2,000? Some people?
I think you said 2,500 deaths per day?
Yep.
Yeah.
Yeah, I mean, 2,000, I mean, almost as many people as died on 9/11 die every day from a heart attack. And then people are all like, oh, let's get the Muslim terrorists. But nobody's like saying, hey, wait a minute. I mean, modern medicine...
How about the dietary terrorists,
Yeah, the dietary
how about we search out the American Dietetic Association?
They're killing people.
Heart Association, and for example, the American Diabetes Association, they still recommend a high carbohydrate diet. I mean, they list all the things that carbs do bad, and then they say, but you still need 60% of your calories from carbohydrates.
Unbelievable.
Yeah. Well, I mean, I've given up on things making sense.
It's one of the things, by the way, going back to the idea that people have the power. It's one of the things I really enjoyed about your book is that, you do say the public are the only people who have the power to change the system. And that's what we're trying to do in these radio shows and in Sott.net and everywhere. So we'd really like to recommend your book. By the way, listeners, the book is called The Cure for Heart Disease, Truth Will Save a Nation by Dr. Dwight Lundell and Todd Nordstrom. So you can get it on Amazon. It's on Kindle as well.
You can also. You have a website, Dr. Lundell?
thecureforheartdisease.net. Although we don't.
Okay.
I'm not very good at posting a lot of new information. There's you guys are way better at that than I am, getting information and truth out, and I appreciate the opportunity to have been on with you today and try to spread a little truth.
Well, you did the research. We just spread the word, so.
Yeah, it's been a pleasure talking to you, Dr. Lundell.
Before we before we finish, you mentioned the omega-6 overload in the book, and there's a lot of people who don't know really about it, about the ratio. Could you tell us a little bit more about it for our listeners?
Yes.
And trans fats.
When we published and promulgated the dietary guidelines for Americans, and then it spread around the world, we were told to reduce our consumption of saturated fats, and if we wanted some oils, we should replace them with vegetable oils, which would be soybean and corn oil, and to a certain extent canola and other seed oils. And these oils contain an essential free fatty acid called omega-6. And all of our the cell membrane is really two layers of lipid with some proteins in there, so it's called a bilipid layer. And lipid is fat, so our cell membranes are fat, and the cell membranes control what goes in and what goes out and how our cells function and all the rest. If we have too much omega-6 in our system, then these cell membranes don't function properly, and they produce pro-inflammatory chemicals that aggravate this process and all the rest of the disorders that are based on inflammation. And in fact, if we get right, I'm laughing because the United Nations is now calling all of these things non-communicable diseases. Once again, as if they're putting a name on it and thinking we understand it better, and I think they're idiots and we're pathetic for listening to them. Nevertheless, I would be so bold as to propose that inflammation is the fundamental cause of aging, premature aging, and even cancers, because it ends up disturbing our homeostasis and reducing the length of our chromosomes, the telomeres, causing all kinds of perturbations in our cellular functions, which then one of those cells is going to start reproducing abnormally because its chromosome has been shortened by inflammation. And so I think all of these things are related to chronic low-grade inflammation, and once again, that can come from lots of places, but the predominant cause in today's world, the predominant source of chronic inflammation today is hyperglycemia. It's aggravated and accelerated when we overload our bodies with omega-6 from vegetable oils. Once again, the official government recommendation. I was amused to see somebody go back and get the data from Australia. Their old study is almost 30 years old, where they said that omega-6s were better than saturated fat. Well, it turns out that a reanalysis of the data shows that that's not actually true.
In fact, I don't know, unfortunately, I don't have it with me, but one of the recent studies about fat, the conclusion was fats are bad for you, and they had a little, star there at the end, and if you actually follow the links, you end up finding out that the studies they were doing were based on trans fats, but the conclusion that they used to promote, the whole low-fat thing was fats are bad for you. Well, of course, you're using modified fats. You're using a huge amount of omega-6s. You're using a molecule that is almost closer to plastic than to oil.
That's correct. And, so for your listeners, and back to and I want to ask you some questions about ketogenic diets, but We need to go back to the way that great-grandmother ate, with bacon grease or lard at this side, and cooking with real food. And I don't want to eat anything with a barcode. Or somebody said, think out, in terms of diet, think outside the box. And I said, pun intended. Yeah, don't eat if it comes in a box.
Exactly.
Yeah.
So fundamentally, we need to get back to natural fats, because there's more and more papers coming out every day that there is no correlation between saturated fat and heart disease. The linkage was always flimsy. The linkage was through cholesterol. And I think that we've destroyed the idea that cholesterol causes heart disease. Therefore, why would I avoid saturated fats? The linkage was weak, and now it's gone.
Especially when you see that more and more people are getting sick and more people are following the low-fat diet.
Yeah.
So,
I was actually going to say something about his out-of-the-box thing. I was going to mention, because when I spent like 10 days in the hospital when I had the inflammation of my colon. I was on multiple antibiotics, and because it was just sort of non-specified. He didn't know what it was. It's just, terribly inflamed and terribly infected. And it's basically because, the fibers and things like that, they seem to really irritate, and they cause damage to the inside of the wall. It starts to become sort of bleeding and bloody, like someone scrubbed it or whatever it is, and that became infected. So that's why I was in the hospital for 10 days. And I came out of the hospital and I said, well, I really have to get control of my eating. I have to learn to eat a new way. And one of the ways that I did is I came up with something called the list, and everything was about what is or is not allowed, and basically it was nothing's allowed. And one of the rules that was on the list was if it comes in a plastic container. if it's like, sometimes you go down to the store and you get meat and it's like wrapped in plastic. And one of the rules was that, you can't eat food if it comes wrapped in plastic, So I thought that was,
Yeah, good advice. Don't eat anything you can get at the convenience market.
Exactly.
We just haven't evolved for that.
It's just not...
So what was it you wanted to ask us about the ketogenic diet?
Well,
because our listeners are asking, actually. They're sending us messages saying...
Very interested in it, and I just spent a week with a man who's documented a 1 year of staying in nutritional ketosis, and there's a triathlete who's going to try to complete Ironman Canada in August in ketosis. And since I enjoy, maybe that's the wrong word, since I compete in endurance events like Ironman triathlons, I'm interested in trying to increase my performance by burning fat instead of carbohydrates, or being so dependent on carbohydrates. So do you have any information about athletics and ketogenic diet?
I do.
Yeah, actually.
I see where this is going. Okay. So, like I said, I used to weigh like 340 pounds, lost a whole bunch of weight, stuff like that, and we decided that we were going to do some work around the yard. And I've notoriously, throughout my entire life, I had no energy and no stamina for doing anything. And I went on to the keto diet and stayed on it I was on it for like 2.5 months straight. And we were doing this, and before that, I couldn't get up in the morning, couldn't wake up. I had this low energy level, very low stamina when working out, very low stamina when going outside to rake the yard or do anything. And when I was on the ketogenic diet, I was getting up at 4 o'clock in the morning, and I was working until about 7 o'clock at night straight, only stopping to have my little keto meal. And, just drinking lots of water, too, and other stuff, and was working constantly, very hard labor. And this is something that I had never really done before in my life. I didn't have injuries, whereas usually when I would try to do, like, yard work or we would, like, repair a wall or something like that, lifting things was really hard, I would constantly injure myself. And while I was doing this very hardcore ketosis, I had one minor injury to my shoulder that's a recurring injury. But within like the next day, I just took like a very, very cold shower. At the same time, I was taking the cold showers, doing this cold shower thing. I ran cold water over the injured shoulder. By the next day, it was better, and I was just able to keep on working and go. And I sustained that, for 2 months straight. And the only reason why I stopped doing all the work is because I had an attack of my genetic disease that I had to go in for surgery, and then I spent 2 months in a hyperbaric chamber and stuff. So I mean, but it was not due to the ketogenic diet. It's just what I have. So that's my story.
Well,
Okay.
I could maybe respond to that question with my experience, because I was doing the paleo diet for
About a year?
Probably about a year, and I noticed I usually do workouts that I guess would be classified as resistance training. Now, don't get me wrong, I'm not an Iron Man like.
He is, dude. The man is insane.
That's a little bit too extreme for me.
He doesn't look like one, but whoa.
But so anyway, I was doing the Paleolithic diet, and I do resistance, weightlifting, but it's resistance training, so it's sort of short bursts of as many repetitions as you can with a slightly higher weight until your muscles kind of give out. Then you do a short rest period, and then you move on to the next set of exercises, and I do like all the muscle groups in my body and that sort of thing. So while I was on the paleo diet, I noticed that I seemed to have all my sort of blood sugar swings, as I called them, they vanished. I used to become, if for example, I had to eat lunch at noon every day before paleo, and if I didn't have lunch at exactly noon, I would start to get headaches, I would get irritable, I would be cranky, my stomach would start growling, I would get hunger pangs, and it was a rather severe reaction. And when I went paleo, all that stopped. I had high blood pressure, my blood pressure was normal, and I noticed that I had more energy for my workouts, but it was better, but it wasn't really amazing, I would say.
Okay.
So then when I went to the ketogenic diet, that basically resulted in, well, when I switched over to the ketogenic diet, I hadn't actually been working out. I'd been slacking off.
Yeah.
So I would work out, twice a week. By the time I switched to the ketogenic diet, I was down to maybe once every 2 weeks I would work out. And so anyway, that made the result that much more amazing, which was that I switched over to ketosis, and I pretty much instantly increased the amount of weight I could do by about 20% on most exercises.
Okay,
so
that's impressive.
That's the first thing. And the second thing I noticed was that being on the ketogenic diet, I could be, doing something physically intense for most of the day, building something, whatever, chopping wood, that sort of thing. And at the end of the day, I would go, geez, I was supposed to work out today. Well, yeah, what the heck? Let me go for it. And I would do a full workout, and then I would go to sleep, and I'd wake up the next morning, and I don't even have sore muscles anymore.
Yeah.
So there's also something. I mean, there's strength, and there's also something that it does to you in terms of endurance and the body's ability to heal itself or regenerate. I'm not sure. I just know that it's been rather phenomenal.
Because once I came to France, I got onto eating way too much carbs. Before that, I had been pretty, energetic, even though I was very overweight. And then I had, just completely tanked in my health because all I started was eating French baguettes and candies and ice creams and stuff and croissant. And once I switched over to paleo, things got better, lost a lot of weight, switched to ketosis, and really amazing results to, I don't think I could really describe how awesome it was, actually.
It's probably about
do you measure
100
with do you measure with urine or blood, or do you just try to avoid?
Yeah, we measured with keto sticks, but they're not very reliable. You kind of get this weird smell, like an acetone kind of breath that lets you know that you're there. But you feel the difference. I mean, you know at a certain point because you feel the difference, and it just...
Yeah, there is a transition phase to take in mind. I would not be trying it and then off you go on an Ironman competition, because a lot of changes are taking place. If you think about the fact that, well, most of our evolution took place in nutritional ketosis state for 100,000 years or more.
300,000, I think it was.
Then to be spending the last 100+ years addicted to sugar and then to switch, there is a transition phase.
Yeah, one of the things that a lot of papers mention, and I'm really looking forward to your opinion if you're interested, is the difference between resistant training and aerobic training. And a lot of people apparently report a reduction in their efficiency when it comes to aerobic exercise, but quite an impressive increase in terms of resistance, and it seems to be related to the changes that have take place in the mitochondria. So if you're interested, that would be really, really, I'm really looking forward to your opinion on the matter. But there seems to be a very different, from the way the body uses the oxygen, a very marked difference between resistant training, which would be more like what our ancestors used to do.
Sure.
Yeah, short bursts of activity that are forced on by the environment.
Yeah. First of all, let me say that resistance training and short bursts of activity, in terms of health and all sorts of things, are probably way smarter and certainly way more efficient in terms of time use than endurance events. Even though I got hooked on doing these endurance events for whatever reason. At any rate, I think once there is not a lot of really hard data yet. Volek and Finney have written a book on low-carb performance, and they have their theories about keto adaptation. And the experiment with cyclists indicated that they didn't have a diminution in performance, but they didn't have an increase in performance. The recent study with gymnasts shows that they actually did as well or maybe better in ketogenesis than they did in a quote-unquote balanced diet. And by the way, what's balanced about overdosing yourself with a toxic substance?
Yeah, exactly.
Anyway, so there's not a lot of data yet, and one person in an experiment of one is Peter Attia has been in nutritional ketosis for a little while, and he actually, depending on the level of exertion at, below aerobic threshold, he actually became considerably more efficient on his nutritional ketosis, but trying to be at 100% peak for sprinting and this kind of things, it may not increase performance. But I don't think at this point in time we have data that once someone's adapted to ketogenesis that it diminishes performance.
Exactly.
That's the thing I wanted to say. I read the cyclist study on that, and I the first thing I noticed is that they kind of did it at a very short period of time where they had the guys on ketosis, and they had been before that carb addicts anyway. They had been really doing the carb stuff, and then they dropped them off that, said, here, go on ketosis, does it increase it? And they said no, and one thing that we've noticed is that there's actually a decently long transition period, and it's different for different people. So ketosis is something you have to be on for a while before you could probably even start to measure that stuff. So you can't just take a guy off of carbs, say, here, go keto, and then a week later put him on a bike and say, did you increase? And I don't think that that's really the best way to test it.
Yeah, that's true.
It is not the best way to test it, and they've pretty well demonstrated that you need a little period of time. And we know that all the chemical reactions that happen in our body are facilitated by enzymes. And if we don't do something, then the level of those enzymes goes down. So we have to up our lipoprotein lipase, and we have to up lots of other enzymes to make us efficient again.
We have a question from one of our listeners, and he was wondering if there is anything regarding increasing fat intakes and improved brain health or mental function. Is there any research that you've done or come across about that?
I can't cite anything right now. There's, as you know, hundreds and hundreds of anecdotes about people feeling mental clarity when they reduce their carbs and increase their fat. But when you stop and think about the brain is 60% fat and most of it saturated fat, and that cell membranes need those saturated bonds. But I have not seen a paper testing cognitive performance by increasing the fat in the diet.
Well, interestingly, there's been studies about the ketogenic diet and neurological problems, Alzheimer's, Parkinson's. That's what actually got us started on this research, because we had a group member who was noticing some Parkinson-type syndromes, and we found out about the ketogenic diet thanks to that study. And it's amazing what they've achieved, actually. And we're not talking about too much of a long-term study or anything, but they noticed a huge increase in neurological functions and memory loss, etc.
Yeah, remission, a lot of remission of symptoms for Parkinson's. I think epilepsy is.
Well, that was it. The very first mention, I think, of the term ketogenic diet comes from studies done very early on with children with epilepsy.
Yeah, in the 20s.
I do remember there was a funny anecdote. I don't remember who it was who was telling me about it. That apparently, like, our brain is like omega-3 fats predominantly, and that the chimpanzee's brain or something like that is more like omega-6s. And so I always thought that it was kind of interesting that the people are constantly getting pushed on these omega-6s, and they keep getting dumber and dumber. and I was like, well, maybe it's because the brain doesn't have enough omega-3s, so it's basically turning into a chimpanzee brain.
Well, Dr. Lundell, you mentioned that Ansel Keys, who became an authority on low-fat diet will save you. Well, he was a vegan, you said?
No, he wasn't necessarily vegan.
He's the guy who wrote the report for McGovern, he said.
Was it someone else? Well, there was something. I've seen something that says that vegetarians have smaller brains.
Well, I could have told you that. No, I don't want to say that. I take that back.
No, but I think it was discovered quite by accident. It wasn't someone setting out to show this, to demonstrate this, but there seemed to be some kind of correlation there. That the lack of fats, essential saturated fats in their diet, was having a direct result on their brain size.
Yeah, I would.
That's.
I mean, these are the same people that use the argument to try to convince you to eat vegetables. They say, yeah, but we're related to monkeys, and they're frugivorous. And I said, yeah, that's why they're still in the trees.
That's right.
It's like, you want to go back there?
If you look at evolution, the human brain, it happened when we got close to the sea and consumed more omega-3s.
Yeah, instead of eating those fats,
Well, did you say when we got close to the sea?
Yeah.
Oh, yeah. That's going
is that the aquatic ape theory?
I don't know.
Have you heard of that?
Not in that term, but I've seen the studies that say that when we started getting more omega-3s, we started getting bigger brains and smarter. And
so, if I'm consuming fish and seafood,
there's a theory. There's a competing theory to the normal ideas about how we developed, and it's called. Somebody wrote a book. I can't remember what the person's name is. It's called the title of the book is The Aquatic Ape Theory.
She's a little old English lady.
Yeah, she's a little old English lady, and she talks about it, and it explains a lot of things about like why we have glands in the places that we have them.
Yeah, and
why we have less hair, why we walk bipedally. She has some good explanations.
Yeah,
for it.
and why our fat is subcutaneous under the skin,
like sea animals, like dolphins and things like that. That we have some differences from apes that are actually not really explained by any normal theories. And so it was an interesting book. I only read like the first couple of chapters of it, and mainly me not being too interested in science, kind of put it down. I said, it's science stuff. I mean, I don't have the education to understand it, so I don't try to fool myself.
Well, all of those things are interesting and fascinating and great topics, but what I've tried to do today is get down to some fundamental biology about why carbohydrates hurt us and why fats are good for us. And we can have a theory about evolution or a theory about this or that. It was not a theory about
No.
High sugars causing oxidative stress and damaging our blood vessels, and high sugars causing glycation of our proteins and giving us cataracts and osteoporosis and arthritis and chronic inflammation and all the rest. So those are fundamental, provable points of biology, not to diminish the fun and the intellectual stimulation from thinking about the theory of why we developed this and why we developed that.
Yeah, but it's clear that we have to do something now about the way we're actually affecting our environment and our internal environment and how we're causing all these problems.
Yeah.
And so, on that note, Dr. Lundell, I think we'll wrap it up. Thank you very, very much for agreeing to come on this Sunday. We can't recommend highly enough to all our listeners that they get his book, The Cure for Heart Disease, Truth That Will Save a Nation. Very informative, and you'll see from it what you can do to inform yourself, inform others. Thank you, Dr. Lundell.
We hope you keep writing.
Yeah, keep fighting the good fight.
Thank you very much.
Yeah, it was good to talk to you, man.
It's been a pleasure.
Okay.
All right. You have a good evening.
Thank you once again to all our listeners.
Yeah.
And we'll be back same time next week on Sott Talk Radio.
Can't get rid of us that easy.
Hold your horses, my belly's aching. Come on, baby, let's make some bacon. Making bacon, it's a thrill. Warming up my cast iron grill. Making bacon, I'm the man. Throw a couple pounds in the frying pan. Making bacon, making bacon. Make it all night long. Don't give me no Twinkie, it'll still be here in 1,000 years. Don't give me no Wonder Bread, and I won't wonder why I'm not dead. Don't give me no vegan meat, the saturated fat is where it's at. Hold your horses, my belly's aching. Come on, baby, let's make some bacon. Making bacon in the stew. Put a big slab on the barbecue. Making bacon in the oven. Come on, baby, got time for loving. Making bacon, making bacon. Make it all night long. Don't give me no tofu. I've had enough to do with that gelatinous goo. Don't give me no tofu dog. Rather be chewing on a sawdust log. Don't have to beg from Jenny Craig. The saturated fat is where it's at. Hold your horses, my belly's aching. Come on, baby, let's make some bacon. Making bacon, smoking wood. The taste of bacon is so damn good. Making bacon, hear it sing. Bacon goes good with everything. Making bacon, making bacon. Make it all night long. Don't give me no diet drinks. If aspartame's gonna rock my brain. Don't give me no Brussels sprouts or any other veggie that insults my mouth. Don't give me no yellow jello. Saturated fat is where it's at. Hold your horses, my belly's aching. Come on, baby, let's make some bacon. Making bacon, I'm a man.